Hello and welcome to the eTech podcast with me, your host, Ryan Morn. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. Hello and welcome to the Avid Technology Podcast with me, Ryan Morn. Now, we've been asked by several listeners of the podcast to do a more in-depth piece on battery management systems, or BMS as they're sometimes called, to explain really what they do and why they're needed. So everybody knows that the key enabling component in an electric and hybrid vehicle is the battery pack. Higher power density and lower cost lithium batteries have really transformed the way that we can store and use power on board a vehicle. Going back to early electric vehicles, they had heavy lead acid batteries. And these were used, but they simply didn't have enough storage capacity per unit of mass to be effective, except in some very special applications like forklift trucks, some industrial vehicles, things like milk floats. Then we had some more advanced battery systems starting to come onto the market. So things like molten sodium salt batteries, these had many issues. They had much better energy storage than lead acid, but you needed to keep the electrolyte at a very high temperature to maintain its conductivity. And also NiCad batteries and nickel metal hydride batteries. But really the step change came about with the invention of commercially available viable lithium-ion battery chemistries that offered significantly improved energy storage density and power factors that made them suitable for mobile applications. We've got another podcast where we talk specifically about lithium battery cells and what's going on with them and the developments in that area. And we've also got some white papers and some other material on our website. So if you want some more information, please feel free to have a look at those. We're not going to go into that in this podcast. We're going to talk specifically about the BMS. And really where the BMS comes into it with a lithium cell is lithium batteries have got some very specific and significant challenges, and it means that they require some quite sophisticated electronics control around them to mitigate these issues. So first of all, lithium batteries are very difficult to manage because they have a non-linear charge-discharge curve. So what does that mean? Well, a lead acid battery is quite easy to know how charged it is or discharged it is, so basically how full it is. You simply measure the voltage and there's a straightforward way of working out the state of charge from that. But with a lithium-ion battery, the state of charge relative to voltage is very flat, and then at each end of the charge curve it's got a very sharp inflection, and these curves vary depending on what kind of cell that you're dealing with. And this means it's very difficult to tell actually what the state of charge is of a cell, or then scaled up of a complete pack. And also, with a lithium-ion battery cell, it's very easy to cause permanent damage by either overcharging or undercharging the cell. So it's really important to make sure that we don't do that, otherwise we're going to damage the cell permanently. So that's a really important safety consideration, because if we undercharge it or overcharge it, it's possible for the cell to overheat as well and get into a thermal runaway condition. And it can also, the thermal runaway can happen if there's damage to the cell or some other things inside. So there's a really important safety role that the BMS is playing there. It makes sure that we can accurately report the state of charge of the battery pack and also monitor the cells to make sure that there's no issues with them that might lead to a problem, to ensure the pack can be safely shut down first. And the BMS typically consists of several separate units. So first of all, there are the module control units, or MCUs, or sometimes these are referred to as slave BMS boards. So these units will monitor the voltage of each cell or a small group of cells in the battery very accurately. The MCU will also typically include some temperature measurement. So it might just be one temperature sensor, but sometimes there's more temperature sensors in there. And the MCUs will communicate up to the master BMS module. So on a typical vehicle, there could be 15 or 20 of these MCU or slave units, and they would all be communicating up to the master BMS. The master BMS would aggregate all of the data, and from that, and also measuring the bulk current flow in and out of the battery pack, it would be able to work out exactly what the battery state of charge is, so that could be reported and communicated to the driver, and also used for controlling other features of the vehicle. So for instance, if the battery is too charged, you don't want to have the regen braking in operation. So that's also actually the regen braking feature there. There's a reason why you normally keep a little bit of, one of the reasons why you keep a little bit of overhead in the pack, to make sure you've got consistent braking feel, because obviously you don't want to be turning the regen braking off if you can help it, because it's going to change the way the car feels to the driver. The capacity of the battery pack is then also limited by the ability of the pack to charge up to basically the weakest cell. So as you're charging up the battery pack, the cells will charge up at slightly different rates, and that depends on basically the manufacturing tolerance stack up in the cells themselves. So in order to make sure that the whole pack isn't constrained by the cell that gets full or empty the quickest, the BMS also works to balance out the cells. It does this by basically switching in and out little balancing resistors, and these discharge small amounts of power from the individual cells or from small groups of cells, and they make sure that the overall pack capacity can be maximized, and basically it's not constrained to the capacity of the weakest cell. So this is also one of the reasons why very fast charging never goes right to 100% of pack capacity, because the balancing resistors need a little bit of time to do their job when we're close to the upper limits of the pack. So that might not sound very efficient, using resistors to discharge the cells as you're trying to charge the pack, and there has been a lot of research gone into ways of more effectively shunting charge around inside the pack to balance the cells out. And it is technically possible, but basically the implementation of that has always proved to be too complex and too costly versus the benefit that you get. And the other big thing that's having an impact on it is, as the production methods are improving for lithium cells, the need for balancing is reducing, because basically the cells are getting much more consistent than they ever used to be. So they charge and discharge at much closer rates now. So that's reducing the need to use balancing systems, but you still do need it with a large lithium battery pack. In some smaller battery packs with a low number of cells, the MCU and the master controller might actually be a single device, so you might not have to have lots of MCUs in a single master. If you had a pack with less than 12 cells in it, which is possible for some applications, then basically you'd have a single unit that was doing all of your BMS functionality. So the BMS also needs to be able to communicate with other powertrain subsystems on the vehicle, and that will be to send messages out to broadcast the status of the battery pack, any inhibit messages if there's something going wrong, and that will typically be by CAN bus, which is a serial communication protocol, very widely used in the industry. Depending on the vehicle architecture, the master BMS might also directly have control over things like the main DC link pre-charge circuit, and also the main power contactors, or it could be controlling those via the CAN bus and a separate vehicle body control unit, or even a power distribution unit controller. The BMS, it'll also interface with the onboard charger, the AC/DC charger, and the offboard charger in order to tell those chargers basically what to do, when to start charging, when to stop charging, when to go from constant current to constant voltage mode, etc., etc. So you can see that it's really safety critical that the BMS can do its job, both in terms of maintaining the battery in a safe condition and also keeping the vehicle in motion, because if the BMS is controlling that main contactor, so basically if the BMS falsely reports that there's a problem, opens the main contactor when the vehicle's in motion, that would mean you would lose power, and that in itself, while you might be protecting the battery, that can be very dangerous as well. So the BMS really is one of the most safety critical systems on an electric vehicle. That's all for today. That's all we've got time for. And just quickly to summarize We can see that the battery management system, or BMS, it's a critical part of an xEV powertrain. BMS is an electronic device. It's needed to measure the state of charge and the condition of the lithium battery, and that's specifically because of the special charge-discharge characteristic, and also because of the safety consideration with the lithium cell. It performs several key functions to ensure that the battery pack capacity can be maximized, such as the cell balancing and the control of the battery chargers. And the BMS will need to be tailored to each different battery pack and powertrain configuration. So if you need help with battery system design or BMS development, please don't hesitate to contact Avid directly. If you check out our website, you'll see that we've got quite significant battery systems and BMS expertise on there. I hope you've really enjoyed today's podcast and you found it useful and informative. Please hit like or leave us a rating. It really helps us in terms of how we appear in people's feeds. We put out a podcast roughly every week, so don't forget to subscribe to our channel for future updates. This last week or two, we've seen loads of people subscribing to the channel on the different platforms that we're on, so that's great. Obviously, lots of people are finding value in this. And don't forget, if you've got any specific questions or there's anything you'd like to know about in particular, send them to us and we'll attempt to try and cover those in future podcasts. So that's all for today. I look forward to speaking to you again soon.